Good morning. Let us study today what are called space lattices. What are called space lattices? What is called unit cell and what is called Bravais lattice? What is called Bravais lattice? Okay. Let us first study space lattices. There are three types of space lattices. One-dimensional space lattices, two-dimensional and three-dimensional space lattices. In one-dimensional space lattices, an array of points arranged in straight line. Okay. So the distance between the 2 points is called A. The distance between two atoms or 2 points is called A. This is the only parameter to describe the one-dimensional space lattice. This is the only parameter to describe the one-dimensional space lattice. Let us consider two-dimensional space lattice. An array of points showing how the ions or atoms are arranged in two-dimensional space. There are two-dimensional space. The unit cell, this is called the unit cell. What is called unit cell? Unit cell is the simplest repeating or smallest repeating unit in 2D space. This is x-axis, y-axis. This is having only x-axis. Here you are having x-axis and y-axis. Whereas in three-dimensional space, you have an array of points showing how the atoms or molecules or ions are arranged in three-dimensional space called three-dimensional space lattice. How the atoms are arranged in three-dimensional space. Then it is called three-dimensional space lattice. In this case, for example, this is the simplest repeating unit cell. This is the simplest repeating unit called unit cell. So what is called unit cell? Unit cell is the simplest or smallest repeating unit in space lattice. It is repeated over and over to form a three-dimensional network. Okay. Now, in the case of 2D, there are three parameters, unit cell parameters. What are the unit cell parameters? A, B and alpha. A and B are unit cell length. And alpha is the angle between the two unit cell length. This is the unit cell for three-dimensional space lattice. This is the unit cell diagram. This is the simplest repeating unit in three-dimensional space. Okay. There are 6 parameters. Unit cell parameters to describe the unit cell. We need 6 parameters. A, B, C are the unit cell length, unit cell length is, for example, this length is A, this length is B, and this length is C. Length, breadth, and height. A, B, C are the unit cell lengths, and alpha, beta, gamma are the angles. Alpha is the angle opposite to x-axis. For example, the angle between B and C is alpha, and the angle opposite to y-axis is called beta. The angle opposite to y-axis. This is y-axis. This angle is opposite beta. The angle opposite to z-axis is called gamma. So there are 3 types of angles, alpha, beta, gamma. For cubic unit cell, A equal to B equal to C. For cubic, A length equal to breadth equal to height. And also 90 degree, alpha equal to 90 degree, beta equal to 90 degree, gamma equal to 90 degree. For cubic unit cell. For triclinic is the least symmetrical unit cell. This is often asked in competitive examination. In triclinic unit cell, okay, A not equal to B not equal to C, alpha not equal to gamma not equal to 90 degree. Okay. So what is unit cell? It is the simplest repeating unit. It is the simplest repeating in the space lattice. So, based on unit cell parameters, the space lattices are classified into 7 crystal systems. We will study further. There are 7 crystal systems depending on the unit cell parameters. Unit cell parameters for A equal to B equal to C and alpha equal to beta equal to gamma, then it is a cubic system. If A not equal to B not equal to C and alpha A length is A not equal to B not equal to C and alpha not 90 degree, alpha not equal to 90 degree, beta not equal to 90 degree, gamma not, they are not equal. Then it is a triclinic system. So there are 7 monoclinic, orthorhombic, we will still study further. Based on unit cell parameters, there are 7 crystal systems. Please remember. Next, what are called Bravais lattices? In 1848, the French crystallographer Bravais showed that there can be only 14 different ways in which similar points can be arranged in 3-dimensional space. He took, for example, spheres. Atoms are considered as spheres. He arranged in 3-dimensional space. The balls, he arranged the spheres, balls, in 3-dimensional space. So that to form a 3D network, only 14 different ways the balls can be arranged, the spheres can be arranged. That is called Bravais lattices. What are called Bravais lattices? He showed that there can be, from geometrical considerations, he showed that there can be only 14 different ways the atoms or balls can be arranged in 3-dimensional space to form a network. Okay, so there are 14 Bravais lattices. Please remember, in cubic crystals have 3 Bravais lattices. Cubic crystals have 3 Bravais lattices. What are they? You have already studied simple cubic lattice, body-centered cubic lattice, and face-centered cubic lattice. What is called simple cubic lattice? Primitive lattice. What is called primitive lattice? In primitive simple cubic lattice, there are atoms only at the corners of the cube. It is called simple cubic lattice or primitive lattice. Okay. In body-centered cubic lattice, that is one of the Bravais lattice. In addition to corner, there is one atom at the body center. In addition to atoms present at the corners of the cube, this is a cube, corners of the cube, there is one atom at the body center of the cube. For example, cesium chloride belongs to BCC lattice. We have already studied. In face-centered cubic Bravais lattice, in addition to atoms at the corners of the cube, there are 6 faces. In a cube. There are 6 faces. 1, 2, 3, 4, 5, 6. You see the cube. How many faces are there? 1, 2, 3. There are 6 faces are there. At the face center, there is only one atom. Therefore, there are 6 atoms. There are 6 atoms in 6 face centers. In addition to 8 atoms. At the corners of the cube. How many corners are there? You see the cube. You see a room. Okay. There are 8 corners. Okay. In FCC, there are atoms present at the 8 corners of the cube and as well as at the face centers of the 6 face centers of the cube. Thank you for watching.